Hey guys, I'm Vanderson here from Houdini VFX. Welcome to the Maggots in a bow. In this course, you'll learn how to simulate wriggling maggots in a bow with full control and realistic motion. Let's go! Let's create first a subnet. Rename this to Maggot Swarm. Let's change the color to purple. Let's dive inside of this node, create a geometry node, rename it to Maggot Scene. Change the color to green. Let's dive inside of this node, create a line here, change the direction to X. Let's resample this node to make more points in between. Change the length here to 0.05. Create a copy to points. Create a sphere here, polygons. Here we are going to create a angle node to change the scale of the sphere along of this spline. To do that, rename this node to Vex P-scale ramp and type a little bit of code here. At P-scale equals, let's give some space here, ch ramp P-scale. Actually here in the resample we need to enable this attribute here, curve U attribute. This is like a UV texture along this spline. Create this parameter, this attribute here, curve UV, along for each point of this spline. And use here in the script at curve U and multiply by some amplitude. Let's enable the attributes here. Let's visualize the copy points. Increase the P scale here like 0.1. Change here to B spline and create like arc formation like this. Let's see if it's working. Sorry. Curve U and it's working, okay. Let's increase the size a little bit, like this. You can increase the resample. I think is enough. Let's convert this to VDB from polygons. Change the scale to voxel size to 0.05. Let's increase the resolution of the sphere here because it's possible to see some faceted shading here. Increase the rows, increase the columns. Convert back this to geometry. You can delete this little piece here just by creating a labs delete small parts. Because the topology is not good, we can create a quad remesh beta. Change the symmetry by Z and Y. Okay. Let's change the color here. Like orange. Okay. For the shader, we are just going to construct the procedural right now. But for the shader, see at the maggot, like stripes here at the render, you can make like a black stripes for it, this concave formation here in the geometry. Let's create that. It's simple. First, we need to create an intersect analysis from here at the point, the copy to points. At the intersect analysis, output intersection segments to convert the disconnected points to polygons. Okay. Create a color here to transfer some color information for the points to geometry. The color of the maggot should be black. You can change the background color here to gray or light, just to see what is happening. And this color here should be red. And create attribute transfer. Attribute transfer, okay. We're going to transfer just the color. Just a small volume distance and threshold. Smaller than that, like 0.05. Is that enough? Let's create here. Convert the color here, the red color, just to a mask at the shading process. Connect here, change this to Vex, copy CD to mask. The script is just a single line, at mask equals at cd.r. Actually, we created a mask here based on the red color of the maggot body. Now we can delete the colors. We don't need the colors anymore. Okay. Let's align this geometry here. Centralize to the world. Match size. Let's create a UV texture to apply the noise shader in the redshift. The UV should be cylindrical, x-axis. And click here, fix boundary seams to avoid the stretch of the UVs. Let's smooth a little bit the geometry. I think like this is working. Okay. Let's create a remesh. Because we are going to simulate our triangle version of this geometry. There's a lot of polygons here. We don't need so many polygons to simulate in the Vellum. Create the remesh around 0.05. Is okay. Let's organize the network here. Let's create a checkpoint here. Ref, Maggot, scene. Let's create the collider, the ball collider. Create a sphere. Uniform scale 3. Let's clip this sphere at the Y direction. Change here to primitive below the plane. Create a poly extrude. Give an extrude of 0.01. Enable this output back here. We can increase it like this, like 0.2, 0.15. Let's create a match size to centralize the word. Make the bottom align with the word position. Change here justify to minimum. Justify Y to minimum. Create a checkpoint. Ref collider. And now we are going to create the swarm of the maggots. First we need a tube. Height around 4.7. Center around 4.1. Let's template the collider here, okay? Let's move a little bit up. Radius scale should be 2. End caps. VDB from polygons here to scatter some points in the density. Scatter. Around the 200 points. Create a copy to points from the maggot to this point here. Okay. First we need to create a randomize attribute to randomize. First we are going to randomize the p-scale, the size. P-scale 1 dimension 0.5 to 1. Let's randomize the orientation here. Orient. Dimensions 4. Direction or orientation enable. Let's change the color. Create a randomized color for each point. That color for the point should be used for in the shading process to make some variant colors for each maggot. And create here a wrangle node, point wrangle, change it to vex name. The script should be a simple line s at name equals maggot underline plus I2A at pitina. This will create this attribute here, maggot. The name in the attribute for each point identify the maggot by the patina of the point. Create a checkpoint here. Ref high poly maggot. Actually, we need to reference this before the remesh, the high poly version for the final render. Now let's create the simulation, the Vellum simulation here. Create a Vellum configure tetrahedral soft body. Move here, connect the reference maggot scene here. You can hide the collider. Create a Vellum pack. Create a copy to points. To copy each, remesh the maggot for the same points that you create before here. Create a checkpoint here to reference this network. Ref point instance that should be connected here. Okay, that's the maggot we are going to use in the simulation, the triangle version. Let's create a Vellum pack. And connect a Vellum solver here. Connect the collider to the third input of the Vellum solver. Before I make the cache, let's create some cleanup in the attributes we don't need. Attribute delete. You can delete all the attributes. Delete all the attributes here except the name. We should keep the name. Delete all the groups. We don't need any group here. And create a file cache. Change the name to cache. Maggot. Move. At the Vellum solver, let's change some parameters here. At the solver, we are going to change the time scale to 0.6. We need to slower simulation. Inside the Vellum solver, we are going to create a pop force. Without any information yet. Let's save the cache and see what has happened. That's the result of our simulation. It's working. I think you should reduce the height of the ball and apply the forces for the maggot body. Let's do that. Change the clip here. We don't need so high ball. Can move it down a little bit like this. Okay. At the force inside the Vellum, we change this to these values here. Surreal size around 0.3. And we need to identify the frame that we are going to start the movement of the maggots. Around the frame 90, we are going to start the movement of the maggots. We are going to animate the amplitude here. First frame should be 0. Let's disable the simulation here. At the frame 80, continue to 0. At the frame 90, change it to 40. That's it. Let's cache again and see what is happening. Actually, we are going to enable the collider ground position here and save the cache. That's the result of the simulation. The maggots fall inside the ball and the frenzy starts, the chaotic. Now we are going to transfer the simulation of this triangle version of the high poly version of the maggot. Let's do that. After the maggot, after the cache, we'll create a point deformer, create a time shift, connect the output of the file cache to the second input of the point deformer, change the time shift to frame 1, and the animated version to the last input. Okay. Create object merge. To reference this guy here, high poly maggot at here, the path, relative path, create a rest position, and promote the rest point attribute to the vertex. This rest attribute we are going to use inside the shader. rest in the original name from point to the vertex. Okay, connect here. At the point of the former, we need to change here the piece name to name. It's working. The high poly version is following the same place of the original simulation. Let's delete some attributes here we don't need. We need to keep the CD. Activate the delete non-selected, keep the CD, keep the mask attribute, and keep the rest. We don't need the name anymore here. Create a global name attribute, create a name, change the name to Maggot, create a trail node to compute the velocity. Change the name to compute Vellum. Here, change to compute velocity is okay. Let's do another cache to speed up the render testing. Change the cache Maggot to render. Actually, change it to a meaningful name. Cache Maggot high poly. High poly sim. Create a checkpoint here. Alt Maggots. Change the color to black. Let's merge the bow just for previews. Create a checkpoint here too. Connect the output of the collider actually here. Change the name to outbow that you are going to use in the shader. Connect here and create a final checkpoint just for previews. Out preview. Change color to black. Let's make a poly bevel at the bow here. Bevel the borders like this. And exclusion, change the ignore flat edges here. We just need to bevel the top border here. Change the divisions to make a round. Okay, make a fuse node, just weld some vertex and create a name attribute. Change the name to bow. Let's go up there, create a loop network, rename to look dive. Let's dive inside the node. Create a SOP import. Change it here to copy SOP layer in the sublayer style. Rename it to Maggot. Ctrl C, Ctrl V this node. Change the name to bow. Merge these nodes. Reference here the maggots. Alt maggots. Reference the bow here. Okay. Create a material library. Create a material assign. Inside the material library, we are going to create just 3 shaders. Actually, we need to create a grid here just for the table. Name it change the name to table. Table. Connect here. Increase the size of the table of 1.5. Create a camera here. Let's view camera. lock the camera and make a good looking position here. I think it is cool here. Okay. Now let's dive inside the material library and create 3 shaders. Redshift. Rename it to RS. Maggots. Copy the shader. Ctrl C, Ctrl V. Bow. Ctrl V. Change the name to table. Outside this node, click autofill materials to fill the materials here in the list. In the assign materials, let's create 3 assignments. One for the bow with the bow material. One for the maggots with the maggot material. And the last one, the table, with the table material. Let's create a dome light. Here in the text, we are going to load our ADR file. And create a redshift node here. Name to RS Maggots Build. Change the resolution for ADTV. In Redshift, click Advanced, increase the sampling to 1 just for fast preview renders. And let's see what is happening in the render. The render is working. Now we need to make some adjustment to the bow here because the bow is faceted. Let's make some subdivisions here. Mesh, edit. Change here to subdivision. Enable subdivision in triangles. And put the bow name here. The bow now has a subdivision. Let's change the color of the materials. First, the table. Let's decrease the luminance of the table, more dark. Okay. Let's decrease the reflection of the bow. Around 0.3 in roughness, I think is okay. Decrease a little bit the weight of the diffuse. Let's go back to white. In the maggots, let's create the structure of our shader here. First, we need to import some parameters here. The color information and the mask and the UV's information to work in the shader. Let's create a RS point attribute. Use display color. Display color. That's the name of variable. Instead, in Solaris, instead of using CD, we need to rename this variable to display color. And connect here just to see if the color is working. Okay, we can see some color information here. To make some color variations here, we create another node GoLine to desaturate this information here. Desaturation -1. We just need the luminance of the colors. Let's zoom out a little bit. Now let's create another point attribute. We are going to use right now the mask to make the black stripes in the body of the maggots. Let's multiply this with our color. Actually, we need to create a vector multiply the color with the mask. It's working, but the mask is inverted. Actually, this look is looking interesting, but the mask we should invert the mask. create a vector, subtract, vector, subtract. In the first input, put one value for the 3-axis. In the second input, put the mask attributes. Okay, the black stripes working. Let's create like some fractal color for the maggots. To do that, we need to create another vector multiply. Here, create a maximum noise. Change the type name to Zada, interesting noise pattern. Here in the input, change the UV vertex attribute to rest. If you not change it here to rest, the worms, you have the sliding UVs. We don't want to do that. Let's look the let's look at the visual of this node. Okay, interesting. Let's create another maximum noise. Change it here to displacement noise. Change the input to rest in the UV attribute. Create a mix. Create a mix to mix these two noises. Let's just see the result of this noise and see the visuals. The noise is looking interesting. Let's create a ramp here. Change the color to an interesting color like a brownish, dark brown here. And the other side like a yellow, orange. And change here more like in the center. Okay. Now you can multiply the final version here. Connect the ramp here at the multiply with the mask and connect the final color to the base color here. Let's see the visuals. The visuals looks interesting. In the ramp here, let's increase the value for this color like 1.5 to create more brighter worms. Let's change some attributes here in the shader, like roughness should be around 0.3. Increase the weight of the roughness to 2. Enable the coat here, a second pass of reflection around 0.3 in the weight, in the roughness 0.1. And activate the subsurface scattering here. The color, both the color and the radius colors of subsurface should be the same color here. The parameters of the colors is MS color and the MS radius. MS color, MS radius with the weight 0.2. That's the look of subsurface of the maggots. Let's see a better render with the camera. Let's see another frame. For the motion blur, we can enable the motion blur here. Create a geometry. Render geometry settings in the Maggots. Reference the Maggot in the primitives and enable here the velocity blur. And now you can see some velocity blur here. That's the look dev in the rendering of the Maggots. Thank you guys. See you at the next video.